You have a table of?
Anti-derivatives.
Let's write that down. That's my table. Okay. All right, the table then. Table of derivatives. So we have a function, f of x, y equals f of x, and I need the derivative, dy by dx, df by dx, y prime, f prime. Okay, all ways to say the same thing, right? We're all familiar with this from Calculus 1. Okay. The most important one of all is?
Power.
Correct. X to the power n. X squared, square root of x, cube root of x, 1 over x, 1 over x squared. What's the derivative of 1 over x? Well, x to the negative 1, what is it? Negative x to the negative 1 minus 1. So, derivative of x cubed is 3x squared. The antiderivative of 3x squared is x cubed. What else?
Power.
That's the power.
Quotient.
No. Table of derivatives, table. Sin x, cosine x, e to the x, tangent x, sine inverse x. You remember those?
Yes.
Okay, come. E to the x, e to the x.
E to the x.
E to the x. What else?
Sin x.
Sin x. What is it?
Cosine.
Cosine x.
N to the x.
Cosine x.
Negative sin x.
Sin x. Tangent x. Secant squared x. Oh, the trig one you must get your hands around. Okay, very, very important. You know your trig derivatives and antiderivatives. Very, very important. What else? Secant x.
Secant squared x, tangent x.
Secant x, tangent x. Cosecant x.
Cosecant x, cotangent x. Negative.
Negative cosecant x. Cotangent x. Cotangent x.
Negative cosecant squared.
Negative cosecant squared x. What else? ln x is a very important one. ln x, that's right. Yeah, ln x.
1 over x.
1 over x. See, I can also give you a handout if you want. I don't believe in those things, but why? You want cutting the trees. You don't run anywhere. You just take it and put it in your bag. Right? That's right. Mr. Harris, how many PowerPoints have you seen in my class? No PowerPoints. Is that no pedagogical benefit of PowerPoint? Certainly not in math. Although some math professors use them, I don't know how. What else?
L of x.
I did 1 over x.
N to the x. Oh, you got it.
A to the x.
Or, yeah.
How about log base v of x? How about log base d of x? And log base 2 of x, or log base 3 of x, or log base 10 of x?
1 over L of b times 1 over.
All right, 1 over L and b times?
1 over.
Very good. How about 2 to the power x, not e to the power x? Something like this. Kind of like e to the x.
A to the x ln of it.
A to the x, yes. Out of b? Yes. Any other ones you remember?
Quotient R.
Those are rules.
Okay.
E to the k x.
That's what rule?
Chain.
It's a rule. What else?
Sine inverse.
Sine inverse. Very important one in Calc 2. What is it? What else?
Sine inverse cosine.
Tangent inverse. Tangent inverse has derivative, what?
1 over.
Very good. And as you can see, this is quite limited. But it will certainly give you some antiderivatives. What's the antiderivative of this? Correct. What's the antiderivative of secant squared x? What's the antiderivative of secant x? It's quite limited. It does not tell us how to find the antiderivative of secant. It's a painful one. It is 5 or 6 pages of some crazy tricks. It is hard, believe you me. Go look it up in your book. Read it next time. How to find the antiderivative of secant x. You think it would be easy, wouldn't you? The problem is that there is no quotient rule for integrals. There is no product rule for integrals. There is no chain rule for integrals. None. That is the problem. Let me tell you what I'm trying to say. How would you differentiate this? You would take the derivative of sine x and multiply it by 3. Now the rules. Okay. What's the derivative of c times f of x?
C times derivative.
Correct. That's it. If you want to find the derivative of this one, the derivative of this multiplied by 2. Not too bad. How about this? What's the derivative of this?
Sine x.
You take the derivative of this, you take the derivative of this, and
Add.
add them up. So you can get a few more things. What's the derivative?
Derivative plus the derivative of g.
Derivative of f, derivative of g, and you add them up. And then you start jumping up and down, and you get excited. Huh? And you say, I ask you now, what's the derivative of this? Cosine x times x squared. You say, well, take the derivative of x squared, take the derivative of cosine x, and multiply them, and you'd be wrong. You have to use the product rule, right? But it's your derivative. It's a nice rule. There's no such thing as integrals. Right? F of x times g of x. Oh, by the way, put a minus here. Put a minus here. What's the derivative of f times g? The derivative of f multiplied by g, the derivative of g multiplied by f, and then you add them up, yippee, it works. But you can't just take the derivative of f and multiply it by the derivative of g. It just doesn't work that way. What else? Huh? This is a problem.
Oh, it's not close.
Oh, yes! When you take good notes, write down what Dr. G also says and doesn't write. Okay. I did say this was the product rule. Did I? Yeah, but you probably don't have that in your notes. But that's where your homework is. Go home and, oh, this is the product. Because to come next week and you look at your book. He said so many things, huh? Go home and say, hey, what is this thing? Oh, this is the product. Let me write it down. Dr. J was too lazy to do it. Right, Mr. Harris? Most of the nodes are where? What I'm writing. Now we'll take f of x and divide it by g of x. Now, f and g are distinguished here. That's to say, f and g are not distinguished here. You could suddenly do f times g or g times f. But f divided by g is most certainly not g divided by f. So when there's a rule, you know that f and g are going to do two different things. So you have to take the derivative of, you take the derivative of f multiplied by g, take the derivative of g multiplied by f, and subtract right away this difference. Huh? And then divide by g of x squared. So g and f are very different. What else? The chain rule. By the way, write this down. The chain rule. The second most important rule of all. Which is the most important rule? The power rule, hands down. Huh? Square root of x, x to the power 1/2, and derivative 1/2, x to the negative 1/2. 1/2 of x. Again, that is distinguished. F of g of x. Decomposing two functions. You scramble an egg, put it in the microwave. Put an egg in the microwave and then try to scramble it. Two different things. Right? F of g of x is different from g of f of x. Composing functions, putting one machine into another machine. Put the x